Hello, welcome all of you. I'm Madhusudan Sohani. I'm taking the course on operations research, game theory. In this course, I'll be taking you through various terms used in the game theory in the sense of payoff strategies, two-person games, zero-sum games, etc., etc. Now let's go to a game. Now see here there is a game. Written on the screen is a game. Player A and player B, can you see these two terms written here? Player A and player B. Player A and player B are two players in this game. The strategies available with player A are called as A1, A2, A3, A1, A2, A3, and they're reflected here. The strategies available with player B are called as B1, B2, B3, B4, and they are reflected here. So the rows A1, A2, A3 are A's strategies, and columns B1, B2, B3, B4 are B's strategies. Now what we are talking about is how the games are played in a complex situation. Like see, let's consider a duopolistic situation. In India and everywhere, the two-player games are very important in the sense they are the simplest form of the games. In the game theory, they are the simplest forms of the games. It's possible to study it to a great extent by studying what are the saddle points, what is the rule of dominance, what is the modified rule of dominance, etc. We'll go through all of that. But before that, let's define this game as player A versus player B. That means we are necessarily talking about a two-player game. Okay, a two-player game. So we are talking about a two-player game. So or two-person game. So I'm putting a tick mark on this two-person game. In our game, there are only two competitors. Like say in India, we have Pepsi and Coke, a duopolistic situation. Pepsi and Coke are the manufacturers of soft drinks world over. And in many places, they are the only soft drink manufacturers or the main soft drink manufacturers, I would say. So Pepsi and Coke, if we take, now what is player A? Player A could be Pepsi, player B could be Coke, or player A could be Coke, player B could be Pepsi. And these are payoffs. Okay. Now, in our game, remember, for simplicity, we are assuming that there are only two players. These two players are such that they're competing against each other. That means whatever is A's gain is equal to B's loss. Whatever A gains, B loses the same amount. Okay. It's like this. In a game of chess, if A wins, B loses. Okay. Fine. And if A gets something like 6 points, B loses 6 points in that game. Okay. So here also, what we are doing is payoffs. What are payoffs? Payoffs are the numbers written inside this matrix. See, these are payoffs. Okay. Now, for example, let's see the A1 row. So far as player A is concerned, he has three strategies, A1, A2, A3. Player A has three strategies, A1, A2, A3, corresponding to strategies A1. Strategy A1. What are the payoffs? It is indicated in the A1 row as 500, 260, 200, 210. These are the payoffs resulting from a player A's strategy being A1. Okay, fine. What does it mean? Now, for example, A1, B1, if you see the intersection of strategy A1 with B1, the number indicated is 500. Okay, the number indicated is 500. What this means is, if player A uses strategy A1 and player B uses strategy B1, the resultant payoff is 500 monetary units to player A. Okay, so all the payoffs are written from the point of view of player A. Player B's payoffs are expected to be or supposed to be exactly negative of that of player A. In other words, if A gains 500, B loses 500. If A gains $500, B loses $500. Okay, fine. So similarly, A1 strategy brings A gains of 500, 260, 200, 210. So player A is thinking, now see, there are various assumptions made in the game theory. One assumption is that it's a two-person game, as I have already explained. It's a zero-sum game. That means whatever A gains, B loses. Okay, fine. Now, another assumption, important assumption, is that both players know about this payoff matrix. So they are fully aware that if I do this and if player B does this, this is the payoff. So the payoff matrix is known to both the players. And now, given the payoff matrix, we have to find out which strategy player A should play and which strategy player B should play. Okay, so we'll come to that in the next class. Okay. Thank you for the time being. Welcome back. This is second lecture on game theory under operations research. Now we have seen that this is the payoff matrix. What it means is like this, that if A1, B1 is the choice, in the sense if player A plays A1, player B plays B1, then the payoff to A is $500, $500, 500 rupees, 500 euros, etc. Now A1, B2 will result in a payoff. A1, B2 will result in a payoff of 260. That means if player A plays strategy A1 and player B plays strategy B2, then the resultant payoff to player A is 260. What is the payoff to player B? It is minus 260 because A's payoff is 260, B's payoff will be minus 260. So this is the meaning of this game. Now let's look at what is maximin strategy and minimax strategy. Okay. Now, see, the games are always two-person games. What we are looking at is also two-person game. See, for a two-person game, it is possible to write a matrix like this. For a three-person game, it will be a three-dimensional matrix. And it becomes much more complicated. For a four-dimensional, for a four-player game, it will become a four-dimensional matrix, and so on. So, like the strategies there could be a combination of A1, B1, and C1. Okay, fine. So here the assumption is that there is only two-player game. So this is the strategies, this is the payoffs. Now let's go to A's optimal strategy. Okay, how to find out A's optimal strategy? Okay. Now see, A goes by the principle of maximin. What is maximin? Maximin stands for maximizing the minimum gain. Maximizing the minimum gain. Okay, fine. So what he does is he has various strategies at his command, such as A1, A2, A3. He examines A1. Okay, from strategy A1, the payoffs are 500, 260, 200, 210, the first row in the matrix. What is the minimum of these payoffs? If I play strategy A1, what will be the minimum payoff from strategy A1? Whatever B does, B may be playing B1 or B2 or B3 or B4. What is the minimum to gain out of strategy A1 if I play strategy A1? So what he does is he goes by row and he finds out what is the row minimum. Okay. For example, let me write down here. Row minimum. Okay. Row minimum in row number 1 out of 500, 260, 200, 210. Out of these four numbers, the minimum number is 200. So I'll write against A1 row 200. Okay. That means 200 is the minimum gain which can be made by using strategy A1. Okay. By using strategy A2, what is the minimum gain he has to make? Now see, the various numbers in A2 row are minus 50, minus 150, 195, and 240. What is the minimum of this? The minimum of this is minus 150. So if I play strategy A2, the minimum that I gain to stand is minus 150. That means B gains 150, I lose 150. As player A, I lose 150. Now, if I play strategy A3 on the other hand, the numbers in the A3 row are 400, minus 20, minus 90, and minus 20. Out of this, the lowest number is minus 90. So if I play strategy A3, the minimum gain from strategy A3 is minus 90. So in other words, from strategy A1, the minimum gain is 200. From strategy A2, the minimum gain is 150, minus 150. And from strategy A3, the minimum gain is minus 90. And A adopts the principle of maximizing the minimum gain. What is maximizing the minimum gain? His optimal strategy would therefore be centered around examining various strategies A1, A2, A3, finding out minimum gain from these strategies, and pick up that strategy which results in the maximum possible value of minimum gain. Okay, fine. So that is what? That is 200. Okay, and it is coming out of which strategy? It is coming out of A1 strategy. So player A says that my optimal strategy is A1, because A1 results in a minimum payoff of 200, which is the maximum value of minimum payoff. Okay, fine. Now let's go to player B. Now remember, the matrix is written from the point of view of player A. So when we are talking about the numbers represent B's loss. Okay. For example, let's go to column B1. Okay. B says, okay. Now see, just as maximizing the minimum gain is A strategy, what is B's strategy? B's strategy would be minimax or minimizing the maximum loss. Minimizing the maximum loss. Because the game is written from the point of view of player A. So the numbers stand for loss to player B. Okay. Now let's see what is the maximum loss from various strategies. Okay, let's look at this column wise therefore, because we are looking at the game from the point of view of player B. Let's look at column B1. Okay. Okay. Now player B is thinking of strategy B1 and the resultant payoffs from strategy B1, provided A is playing either A1 or A2 or A3. Okay, fine. So what he is doing is, what is the maximum loss from strategy B1? What is the highest number in strategy B1? Highest number in strategy B1 is a number 500. So if I play B1, if B, I'm player B right now, if I play strategy B1 and if A plays strategy A1, the maximum loss to me would be 500. So I'll write the maximum loss. This is row minimum. Now this is column maximum. Okay. Column maximum is a loss of 500 to player B. Now from strategy B2, similarly, the loss would be the column maximum, that is 260. Column B3, the loss would be the highest number in column B3. The three numbers are 200, 195 and minus 90. So the maximum value out of the numbers is 200. Therefore, the maximum loss would be 200 if I place strategy B3. And if I place strategy B4, the maximum number out of column B4 is 240. Okay. So what are the numbers? 500, 260, 200 and 240. This is what? This is maximum loss that I'm going to incur by adopting strategies strategy B1 or B2 or B3 or B4. So, and since I'm interested in minimizing my maximum loss, I'll be choosing the minimum out of the maximum values. Okay, so column maximum has been tabulated. What are the column maximum values? 500, 260, 200, 240. This is the maximum loss by paying strategy B1, B2, B3, B4. Out of this, which is the minimum? This is the minimum. So this is the minimum value of maximum loss, minimizing the maximum loss. This is strategy of player B. Therefore, this is the optimal strategy. That is B3 is the optimal strategy for player B. Okay. Now see, what are the optimal strategy for player A? The optimal strategy for player A was A1. Okay. And what is the optimal strategy for player B? B3 is the optimal strategy for player B. Okay. And can you see that the number that we are talking about, that is the row minimum of 200, we are talking about the row minimum of 200, which is also the column maximum. Okay, the row minimum of 200 is also the column maximum. Therefore, the correct strategy for player A would be A1. Sorry, we are writing the strategies in small letters. A1, and player B, the strategy would be B3. And since these two numbers are same element, that is 200, A1, B3 intersection is 200, the game stands solved. Okay, and what is this game? This game of player A versus player B, the optimal strategy for player A is A1, and the optimal strategy for player B is strategy B3. So how do we write this? How do we write this? There's a particular way of writing the expression. I'll show you how to write the answer for the game theory question. Okay. Player A, colon, optimal strategy, A1. Okay. Player B, colon, optimal strategy, B3. And value of the game, V for value of the game is 200. This is the way to write the answer to the game theory question. Now see, this is a very simple game, where the row minimum coincided with column maximum, and if there is an element like that, that itself is the value of the game. Okay, and this game which has row minimum coinciding with column maximum, this is called a saddle point. So what is a saddle point? Saddle point in a two-person game is the value of that element which is row minimum and column maximum at the same time. Okay. Now look at this. Let's if we were to solve for saddle point. Okay. What we go on doing is we mark the row minimum by a certain number. Okay. Like see 500, 260, 200, 210. What is the row minimum? Row minimum is a number 200. So I'll mark it with a dot. Okay, I have marked it with a dot. Row number 2, minus 50, minus 150, 195, 240. What is the minimum value out of this? Minus 150. Okay. Row number 3. What is the minimum value in row number 3? 400 minus 20 minus 90 minus 20. So minus 90 is the lowest value in row number 3. So player A had 3 strategies, A1, A2, A3. Player B has 4 strategies, B1, B2, B3, B4. And actually, see, there is the thing called as a square game where both the strategies for both the players are equal in number. Okay. For example, here, player A has 3 strategies, player B has 4 strategies. So this is not a square game. This is a rectangular game. Now we have marked the row minimum. Now we'll mark the column maximum in some other way. For example, column number B1, first column, 500 minus 50, 400. What is the column maximum? Let's mark it by an asterisk or something. So I'm marking it by an asterisk, 500. Okay. Second column, B2 column, 260 minus 150 minus 20. What is the highest number in this column? 260. So I'm marking this number with an asterisk. Okay. Column number 3, that is B3 column, 200, 195 minus 90. The highest number is 200. So I'll mark 200 by an asterisk. And column B4, the last column, 210, 240 minus 20. So the highest number is 240. So I'll mark it by an asterisk. Can you see that one particular number in this matrix has got both the symbols? Column, this is what? This is row minimum, and this is column maximum. Row minimum, column maximum numbers have been marked. A particular number in this matrix is row minimum and column maximum at the same time. That number is available at the intersection of A1 and B3 strategy. Therefore, A1, B3 is the solution of the game. Okay. So what is the saddle point? Saddle point is that number in the matrix. If that number is row minimum, it's also column maximum, then there is a saddle point, and that number is equal to the saddle point. So in other words, there could be games with saddle point or without saddle point. For example, I'll show you a 2x2 game. Okay, player A has only 2 strategies, A1, A2, B1, B2. And what are the numbers? Let's see, 8 minus 3 minus 1, 10. Okay. Now let's try to solve this game using the principle of saddle point if it exists. Okay. 8 minus 3 minus 1, 10. These are the strategies. B1, B2 are strategies of player B. A1, A2 are strategies of player A. So let's find out if this game has a saddle point. So let's mark the row minimum by a symbol called as dot. Row minimum in row number 1, 8 and minus 3. The minimum value is minus 3. So I'll say this is row minimum in row number 1. In row number 2, minus 1 and 10 are 2 numbers. So I'll mark this number, which is the minimum value in row number 2. Now column maximum. If I mark column maximum by a different symbol, like say asterisk, column maximum in B1 column is 8. Column maximum in B2 column is a number 10. And therefore, there is no number in this matrix which has got both the symbols, that is a dot and an asterisk. Therefore, this game does not have a saddle point. What is saddle point? Saddle point is that element in the matrix which is row minimum and column maximum at the same time. There is an easier way of doing this. Let's look at row number 1. Okay. Now let's remove this. Let's presume that the game was like this: 8 minus 3 minus 1, 10. Okay. Now let's examine the matrix row by row. Row number 1, 8 and minus 3 are the numbers. Which is the lowest number? Minus 3. Is this number minus 3 the column maximum? No, because column maximum is 10. So row number 1 does not have a saddle point. Row number 2, the saddle point is not located in row number 1. The saddle point, is it located in row number 2? Let's see. What is the lowest number in row number 2? Minus 1 is the lowest number in row number 2. Is this minus 1 also the column maximum? No, because column maximum is 8. So none of the row minimums are column maximums. Therefore, this game does not have a saddle point. When there is saddle point like this game, the first game which we have seen had a saddle point, that number was 200, and the strategies were A1, B3, and how the strategies are written. One way I showed you. I'll show you another way of writing the solution of the game. Player A, which strategy are you recommending to player A? A1 strategy is what you're recommending to player A. So A has A1, no A2, no A3. So 1, 0, 0. What 1, 0, 0 means? A1, A2, A3. The proportion of A1, A2, A3 should be 1, 0, 0. That means all the time he should play strategy A1. Okay. Now player B. What is the strategy recommended to player B? B3 is the strategy recommended to player B. So he should not play B1. He should not play B2. He should play B3, and he should not play B4. So what is the solution of the game? A strategy is 1, 0, 0. B strategy is 0, 0, 1, 0. And what is the value of the game? Value of the game is 200, which is a saddle point. So this is the saddle point of the game. Now see, in other words, we have learned a few things. 2-person game, zero-sum game. A's gain is equal to B's loss. Therefore, it's a zero-sum game. A may have multiple strategies: A1, A2, A3, A4, A5, etc. B also has correspondingly B1, B2, B3, B4, etc. The game is always written from the point of view of player A. So B's gains are exactly opposite of player A's gains because it's a zero-sum game. What is a zero-sum game? The gain of both the players put together is 0. Okay, that's why it is called as a zero-sum game. So 2-person zero-sum game with saddle point is what we have seen today. We'll see some more examples of this in the next class. Okay, thank you.